So actually starting with our first Lex program, that is have a look at this program that is actually equal to float. And talking about the Lex declaration, we have already talked. So we will not discuss the basic format of this Lex. But yes, let's discuss what this program does. This program does is actually we have written here. That is what this program will do. This program is actually equal to write a Lex program to identify the digit, character, word, float, and identifier. And we have to also prove whatever exactly not. So how to identify digits, floats, words, identifiers, and characters in a Lex file? We have different regular expression for everything, and we will use that and we'll call a function which will actually identify or print the stuff into it. So we have made this int main function here, and in this we will do only work is actually we will say that enter a string, and then we will call the while x here. The while x will actually call this whole stuff. These all block between these two percentile symbol will actually work as the while x YBLX program or YBLX function. So in the start we have this flag variable which doesn't need to be created because we are actually creating a local flag variable on the fly in every different block of the regular expression implementation. And thus we don't need to make it. What is this thing doing here is actually we have a YBLWrap function. We have a by-way wrap function which is already been made in the Lex declaration, so it used to actually clash, and it needs a by-way wrap function inside our Lex program. So we can do what is actually we can undefine the by-way wrap which is already being declared, and we can define its value to be 1. So one thing is this way in which we can just get around the warnings which are being generated whenever we will actually try to compile the lex.yy.c file with GCC. But another thing is actually just declaring it downwards. Yeah, after the anti-main, what we can do is actually declare it y by wrap, anti-y by wrap, and then um, this function actually takes as argument nothing, and we can just return 1 into this function, and it will also keep sign its warnings. Yes, that's another way. Now what we have done is actually identified a character. A character according to this program is actually any character which is actually among the small case letters of alphabet, or say uppercase letter of the English alphabet. So whenever anything like that is in a single character is actually encountered, so we will actually call the display function here with the byte text as the value with the percentage string that what you have encountered and the flag here. Now let's have a look at this function that are actually equal to this. Now in this function we have this character array which will be actually containing all the characters, and then we have a flag which will tell me that what was that character. That character is the identified regular expression's value, which is actually being identified with a particular flag. So we have kept the if conditions here which will actually show me which will actually get branch off according to different regular expressions from which it is being branched off, or from where this function has been called. So we have this identity flag. Whenever, okay, I have in my mind set up this flag that is equal to floor. So I have set up this was the floor flag was actually set for the regular expression of a single character. So in the if condition, whenever a 4 is encountered, then I will say that percent s is actually a character, and then I can actually pass the value a into the percent s symbol, and the a is actually the byte text that was actually being pushed here as the value that what has been identified as a character. Now the next thing is actually for the word. Whenever you actually get anything which is actually carrying a single character or more than a single character, then they comes into the word according to the definition. So we have actually set a flag of 1 and then passed a flag of 1 here. And inside this function we have printed the word that it is a s is a word that is actually y text is a word for the flag value 1. Coming to the next, we have actually identified the digit. So the regular expression for a digit is actually the numbers from 0 to 9 one or more times. This plus actually indicates the number, the particular class which is in front of it to be one or more times. So whenever this encounters me something like say 1 come or say 19 comes, then it will actually get identified through this regular expression, and then we will call this function with the private text value and the flag with it. Now, talking about the identifier, the identifier must actually start with this. So, identifier must actually start with underscore or say small letters or a capital letters, or then it must be followed by the small letters or the capital letters of alphabet or 0 to 9 in some digit, and an underscore is also allowed in between its name. So yes, the second thing is actually optional and can come zero or more times. So we have fitted a star here, and then we have to set the flag. We have set the flag of two here inside, and then pass inside the this function. The this function is actually pre-calculated for it, and with the flag of two, it actually prints the identifier inside the if condition. Talking about the float, what's the regular expression for a float? The float is actually what is actually according to me. So this is actually according to my definition. But yes, floats are actually what which gets started with dot and then ends with at least one character. So in this condition, it must have something like this, that is dot 9. So this will be also identified as float. But yes, if it has characters before it, so we can say something like say 0.9, and yes, it will be also identified as a float. So we can actually set the previous digits as being optional. So we will put a star after 0 to 9 as the previous condition, and then a dot is actually necessary. We can also do something like this. And then we have the 0 to 9 as characters or say digits after 8 one or more times, means at least one is necessary. And we have set the flag of 3 and passed to the this function. We have made a generic function. So 3 will be in the if condition of flag is equal to 3, then we have printed that it is a float and that y by text is also being printed. Now, other than all of these conditions, if anything happens, then we can actually say like dot and then empty flag is equal to minus one. If anything else happens, then we can say that yes, we can pass a minus one flag also here, and then minus one flag can be actually we said that it is actually something else. It is actually something else. So we can also print the string then what has been identified as something else, which is actually being known parsed by the above things. When all this will happen, when all this will this remember that this what display declaration will be done into the third block of lex program. That is actually okay, there are three blocks which are being separated by the percentage symbols. So it will be actually declared in the third block, and before whenever as the compiler will see this function, if it is actually being declared here as a prototype, then the compiler will get to know that this type of function can be actually be found later on in below. But if it will not declare its prototype, then it will say that yes, it is not being identified, and it will generate some error. So yes, we have this here, and then also we need a file say hash include stdio for actually using the printf functions which we are actually using below. So we need this file, and let's actually try running it. We will run, and this spyware wrap declaration is necessary to not to generate errors. So we'll go to this directory. So closing the previous programs, and we'll go to one, and then in this directory we can try running flex pg.l, and it runs successfully without any errors. So yes, now it has already generated this lex.yy.c file, which will be actually compiled with the gcc. All the paths must be set it for using gcc and flex already into the environment variables, and then we will just compile the lex.yy.c file, and it will generate me by default an a.exe file, which you can see here, which is being generated by the lex GCC while compiling lex.c, and we can run that file by using a.exe. And when this file runs, it is actually saying me that enter a string, but it is actually waiting there, means it is waiting for some input. So I can say something like say 1, and then 1 is a digit. I can say something like 0 0.9. 0.9 is a float, right? Great. And then we can say something like say, underscore. Underscore is an identifier which is also a valid identifier, so we can say abc ABD, then it will be actually identified as an identifier. And we can say something like say what is actually being left character. Yes, we can use hash. So hash character is actually something else. So we have defined the character to be a single character like a, which will be identified as an identifier, sorry, character. And something else other than those which are not being declared in the regular expression will be actually identified with something else. statement. So how do we stop this program? We can use a control C statement here, or control plus Z to actually stop this program. But another thing which we can do here is actually just declaring a regular expression to actually stop all this parsing. We can just say something like, say, whenever you find a trait, whenever you will find a trait, then do what is actually return 0. Something like this then can be done. What this statement will do is actually, whenever an trait is actually being encountered, then it will return towards what where from where it has been called. So in the anti main we have called the by legs. That's why this all regular expression declaration is running. And whenever we return from that statement, so we will return here, and from this anti main it will get returned, and the whole program will close. So we can try running this too, and we can try flex gcc enter a string, and if we try normal things like a, it is a character, amy, this is a word, and say hash, then it is actually something else, but at rate, then it will close the program. And that's how this program will run. So that was just a small example of flex program, and that was the first flex program. And thank you.